In this video, I'm going to be putting local AI models to the test on my brand new MacBook Pro M5 Max with fully maxed out specs. I purchased this for $5,399 yesterday. It's got 128 gigabytes of unified memory, and we're going to be vibe coding and testing local models inside of my Hermes agents to see how good is this machine at running local AI models. Later this week, I am going to be putting my NVIDIA DGX Spark head-to-head with this MacBook Pro. If you want to see me test more local AI models, make sure you drop a like on this video. I do have a like goal of 250 likes on this video, so if you haven't already liked the video, make sure you do so. But check out artificial analysis. I want to show you guys the difference between frontier AI and local AI with this data. So on artificial analysis, you can see that GPT 5.5 currently has the best coding model on artificial analysis. Look at this chart. So GPT 5.5 is here at 59.1. The frontier local AI model is Gemma 431B. If you look here, it's at 38.7, which is quite a wide gap. 38.7, that's a lot. But what I want to show you guys is let's check out where GPT-5 was on this. So look at this. We're going to just do GPT-5. Look at this. Gemma 431B is more intelligent than GPT-5. And GPT-5 was the frontier model just like, what, 9 months ago? So this is how fast open source is catching up, is that yes, the frontier is always going to be the frontier, but you can now run a model locally that is as good as the frontier model just 9 months ago. So it's very important that you stay up to date with local AI models because they're becoming a lot better, but we're going to test it out in this video. We are going to be testing out the top open source models that can be run reliably on an M5 Max, which is Qwen 3.635B, Qwen 3.627B, and then Gemma 431B. So those three models that you just saw. But let's put it to the test. Let's stop talking. Let's start vibe coding with these models, and let's also test them in my Hermes agent. But with that being said, make sure you like and subscribe if you haven't already, and join the BridgeMind Discord community of over 10,000 builders and entrepreneurs. And with that being said, let's get right into the video. All right, the first model that we're going to test is Qwen 3.635B. And note that we are running the Apple Silicon optimized version. That's what this MLX is for, is that this is a model that runs very, very well and is optimized for the M5 Max. So let's submit this prompt, and I'm just going to let you guys watch this. I did get a chance to test this before, and I have to say, I'm very surprised at how fast this is able to output tokens. So it thought for 7 seconds, and now it's already outputting tokens. And if you've tested Gemma 431B before, which I have, and we're going to test a little bit later in this video, but you guys will note that that is a little bit of a slower model, and I don't know how many tokens per second Qwen 3.635B is currently outputting, but look at that. We've already generated over 150 lines of HTML. One thing that you guys should know before this finishes its output is that my computer is heating up right now. So here's our output, and look at this. I mean, if you guys know from the BridgeBench lava lamp tests, you'll know that this is actually a pretty quality output. Look here, you'll see that the tokens per second was 104 during this output, which is actually blazing fast. That's well over 2 times faster than GPT 5.5 and Claude Opus 4.7. Now let's give Gemma 431B a test. And remember that this one was actually ranked as more intelligent on artificial analysis, but I'm pretty sure it comes at a significant speed reduction. Yeah, so look at this. This one is way slower. It thought for 26 seconds, and so far it's only outputted less than 50 lines of code. Now, while this is running, I do want to show you guys a look at the memory that's currently being used on my machine. So if we pull up Activity Monitor, you will see that I'm using 90 gigabytes of memory on this machine. You can see 22 gigabytes is being used by Qwen 3.6 and 20 gigabytes is being used by Gemma 431B. So for example, if I wanted to go and give a prompt to Qwen 3.635B right now, I could. But look at that, Gemma 431B is now done. Here we have our lava lamp. You guys can be the judgment on this of if you think that is good or not. But let's actually go check out the speeds. And if you look here, yeah, that is a completely different model. The output token speed is 21 tokens per second. So Qwen 3.6 ended up being about 5 times faster than Gemma 431B. Let me know in the comment section down below what you guys think. I did just run Qwen 3.6 27B through this lava lamp test. Here's the output. I don't like it as much as the 35 billion parameter model did, and the speeds on this model are much slower. If you look here, you can see that the response tokens is only 28 tokens per second, meaning that the Qwen 3.6 35 billion parameter model is about 4 times faster than the 27 billion parameter model. Qwen 3.6 35B is definitely my favorite out of these 3 models that I've tested so far. The main reason is because of that speed. I mean, I think it was running at 104 tokens per second. So let's now test this in OpenCode and just see like, hey, how fast is this able to operate in a real code base? If you guys look at the BridgeMind.ai website here, I just want to make a quick update. You guys can see that it currently says that we have 74,000 subscribers. Let's just prompt OpenCode and prompt Qwen 3.6 35B to change that to 76,000 subscribers. I want you to note that we now have 76,000 YouTube subscribers. I need you to update accordingly. Let's see how this functions. All right, it's already asking for permission to get it done. Let's see what it does here. Wow. Yep, it's already done. So look at that. It only thought a few seconds and it was able to finish it. Let's now pull back up the browser tool here and look at that. Boom, 76,000 subscribers. So that's obviously a relatively easy task, but it does show you, hey, these models are able to operate in a real code base. All right, guys, check this out. I'm currently in the middle of nowhere. I have no Wi-Fi connection. And for this next test, I'm going to be testing Gemma 431B. I'm going to be testing Qwen 3.635B and Qwen 3.627B while we're out on this dock in the middle of nowhere with no cell service or Wi-Fi. All right, guys, so the first thing that we're going to do is we are going to be using BridgeSpace today, which is a BridgeMind product. This is the core product in the BridgeMind ecosystem, and we're going to create a new BridgeSpace. I'm going to CD into my desktop, and then I'm going to CD into BridgeMind, and we're going to be launching 8 OpenCode agents inside of this workspace. And once we get these agents configured, we're going to be launching, like I said, Gemma 4, Qwen 3.6. So all of these defaulted to Qwen 3.635B. Let's just give these some prompts. Let's pass this one into this. I need you to launch 3 sub-agents and do a complete deep dive on the SEO of the website. Note that you do not currently have internet access, so don't try searching the internet. Just review the code for reference and identify ways that we can improve our SEO for the website. So we're going to pass this in. Let's switch this one over to, I think I'll go to models, and then I believe, yeah, look at this. So Olama, these are the local models that I currently have access to. If you guys look, you can see that I have Gemma 4, 31B, and then the 27 billion parameter model and the 35 billion parameter from Qwen 3.6. Let's switch over to Gemma 4, 31B, and let's give this one a prompt. Let's actually have this one do like a single HTML test. Let's do BridgeMind. Hold on. Let's just have it create a single HTML file in the root directory. I need you to create a single HTML file of a first-person shooter game in the root directory on this computer. I should have a AR-15 and an RPG, and I should be able to navigate a map and shoot enemies. Once you are done with your output, give me the URL so that I can test this in a browser. So we're going to submit this one as well. And this is also going to be a good test of how well is the Mac able to hold up when you are running like a ton of models at once. We'll take a look at Activity Monitor here in a second and just take a look. All right, guys. So I did prompt Qwen 3.627B. So we're currently running
3 models. We don't even have any output yet from Gemma 431B. Qwen 3.6 35B is still exploring a task. If we click into this, we can see what it's doing. And then Qwen 3.6 27B is currently reading files. But I can tell that my computer is like lagging out and the performance is like really affected right now. So if we go to activity monitor, what you guys are going to see is that I'm currently at 116, look at this, 117, 119, 120. So you guys can see that when you're running these models, they actually do take up a lot more space. You can see, I don't know what model this one is, but it's probably Qwen 3.6 35B, but it's taking up 40 gigabytes right now. And then we have, obviously, this is the Gemma 4, which is 35 gigabytes. And then we have the 27 billion parameter model, which is 28 gigabytes. So these are all taking up quite a bit of space, which is obviously why you need such a good computer to be able to run some of these models. But yeah, that's the performance here. I'm not super impressed with the performance. And that's the thing with local models, is that when you are dealing with local models, you can't really compare these to frontier models. If I was using Claude Code, I would be able to rip these prompts no problem, and I wouldn't be having issues like this one that I'm having with Gemma 4 31B, where, hey, this isn't even doing anything, right? Like this is still thinking, and that's an issue that I've seen with Gemma 431B in these tests, is it's a very slow model, a little bit inconsistent too. And then Qwen 3.6 35B here, this one is like hardly working. So I think that if there's anything that I see, it's like, okay, you're obviously like not going to be able to use these in a legitimate vibe coding workflow, especially if you're actually running these on. Look at this one. This one thought for 49 seconds. Now I have all the context I needed. The design system from Design MD, root layout, global CSS, and full page component inventory. Let me launch 5 subagents in parallel to audit different areas. So we are launching these subagents. Look at this one. The file is very large. Let me continue reading more critical files in parallel. So this is obviously an issue. Gemma 431B is not even working, and then Qwen 3.6 27B and Qwen 3.6 35B are not doing the best job. So we do have some of the output from Gemma 431B. So this did think for 8 minutes, and then it outputted all of the HTML at once. Now I have loaded this in my browser, and look at this. When I do click to start, nothing happens. So it didn't actually create a working HTML file with this single first-person shooter game, right? So that's a problem. That doesn't work. If we pull up BridgeSpace, this 35 billion parameter model is finished here, and it just kind of got confused, and it looks like it didn't even do anything. So that one didn't work. And then over here, we do have, if we expand this one, it is working on, if these are the different subagents, it is launching all these subagents. It has 5 subagents that you guys can see are running, but it is a little bit slow. And if we pull back up activity monitor, we're still at 116 gigabytes. So I don't know if the camera probably is lagging out a little bit, and the reason for that is because I'm running these models on my machine, and I'm just not seeing the performance here. And even though they say on artificial analysis that this is the performance of GPT-5, when you're actually using this on a machine, you don't get that same performance, you don't get that same efficiency. So it may be able to run super well under supervised conditions inside of artificial analysis benchmark, but in real world use cases, I'm not seeing the reliability and performance when you're actually trying to use these models inside of a vibe coding workflow.
Okay, for our last test here, I am going to be testing Qwen 3.6 35B inside of a Hermes agent, and we'll see how it performs there. Now, for this test, I'm not going to be running all 3 models at once. As you saw from that last test, that was really not good. So let's just test it with a singular one. I need you to review your skills and help me find trending AI news today. All right, guys, so this one's doing some tool calls now, and I've got to say, out of all of these models, Qwen 3.6, I mean, this is the best one. Let me fix both issues. I'll run web searches. So now it's doing web searches. We're just going to do always allow here and let it do its thing. The tool calls with this model are actually pretty good. Look at this. You've got 2 tool calls, 2 tool calls, 3 tool calls, 2 tool calls, a lot of tool calls here. Look at this. This tool call took 46 seconds to complete. I've got to say, guys, even though it runs at over 100 tokens per second, it actually takes a lot longer to finish what it's working on versus a more intelligent model such as GPT 5.5. Now, it is compiling a final report right now, and we'll see what it comes back. Really, the sole purpose of this is to find like the biggest news sources. You can see that the most significant developments I'm seeing from May 26th are Google announces Gemini Omni, Pope Leo urges AI disarmament, White House $9 billion investment for intelligence agencies, Trump AI EO event canceled, Anthropic Project Glasswing update, NSA releases MCP. So, I mean, these things are relevant in the news. So would I say that this did a good job? I would say that, yes, I've been seeing these things in the news as well. This is what I've seen in the news. So it looks like it did its job. But I will say that this has taken 5 minutes now. And pretty much it's just doing like a simple internet search to find the trending news of today. And then it's creating a report from that. And I do feel like even though this runs at 100 tokens per second, when it's actually doing the work, because it's not as intelligent as a GPT 5.5 and doesn't have the same tooling, it ends up taking much longer, even though GPT 5.5 is a slower model. All right, so here's the final output. So you guys can look at this, and I mean, it did give me quite a bit of information. Here's all the information about Gemini Omni. Here's all the information about Pope Leo. Here's all the information about Trump aborting the AI executive order. Here's all the information about Anthropic basically providing an update on Project Glasswing, and then an update with the OpenAI named leader in enterprise coding agents. I don't know what that even is. This one's from May 22nd. So you could kind of say, oh, did that one do a good job about finding trending news from today? I don't know. Based off of what I'm seeing, I do not suggest that you guys go out and buy an M5 Max if you want to test local models. I'm just not seeing that performance. But one thing to remember is this chart right here. We do now have local AI models that are 27 billion parameters that are outperforming GPT-5 in intelligence and in coding. Look at this, Gemma 431B and Qwen 3.6 27B both beat the frontier model just from 9 months ago. But we have other issues. You know, think about this model. This was probably served from Google, right? Like when they indexed this, when they tested this in artificial analysis, they were probably testing the model on like Google infrastructure, right? From a Google data center or something like that, right? But if you're testing it on a local machine, like an M5 Max, the performance, the speed, the efficiency ends up being a completely different story. And I'm not testing this on like a cheap computer. This is a $5,399 computer. I paid good money for this. And local models just, I'm not seeing this performance when I'm actually running them locally. Yes, the model may be this intelligent, the model may be this good at coding, but when you're actually running it locally, it ends up performing far worse versus however they did this test, which is probably just from a data center. That's gonna be it for this video. If you guys like this video, make sure you drop a like and subscribe to BridgeMind and join the BridgeMind Discord community, the home of the vibe coding movement. And please, if you have any comments or suggestions, please let me know in the comments down below. And with that being said, I will see you guys in the future.